Hello there, I'm back again. This little video is all about cobbling together this set of starter rollers. Now, I haven't bought any designs. I believe there are designs available on the web. Well, the first thing I've decided to do is remove the bendix from this old starter motor. And the bendix is held on simply with one circlip and a shaped washer, very similar to the way valves and valve springs are held together with a collet and a tapered sort of collar. Well, as you can see, these little clamps seem to have squashed this spring enough, and I just need to dig out this circlip now. So like all circlips, it's in danger of flying off. I'm just wondering if it would help if I squash these springs a bit more. I think I should. Right, back again shortly. Right, you may be able to witness this wretched circlip flying off into a low Earth orbit. No, I think a wider screwdriver would be a good idea. I think this is doing very well as circlips go. It seems to be extremely tortured. It's gone. I wonder will I ever find that again. One of these days. Anyway, the circlip is now gone. This circlip retainer is removed. The spring is removed. And now I've got to undo all that pressure. Anyway, that's another story. So then the next washer comes off, and then the bendix should come off. Oh, that's interesting. That part comes off as well. Ah, very interesting. Okay, well look. Oh, I see how this works. Oh, I might be able to use these bits actually. That's got a nice set of splines in it. Well, there's the components of the bendix. That's a very powerful spring. I think those little toe clamps probably weren't man enough for that. This just gives you an idea of the overall plan of this contraption. As you can see, I've put some masking tape on a piece of aluminium flat. I plan to drill through these, two of these, to make all the various holes so that it's all fairly well symmetrical. A little bit on chain tensioning now. Let me just set up the sprockets. Now, roughly speaking, this is the way it's going to work. This will be the drive sprocket here, which the end of the starter motor shaft will be supported with one of these bearings. Then there's a little idler pulley. Now, the reason for the idler pulley being here is that this bearing and this roller is going to stay put. And then if for any slack in the chain from there to there, I'll have this one then to go up and down and tension it. On the other end, down here for the other roller, this bearing will be able to tilt a little bit like that. It'll pivot down here. And as you can see, that's the plan. That means that in effect I'll be able to tension this pulley ever so slightly and deal with any chain wear that is on the long run here. This is probably going to be the most significant amount of wear because it's the greatest distance between centers. But for all of that, I should be able to deal with that. And this little tensioner here will work, and all of the chain runs will go over like that, and this will all work fairly well. Well, that's the plan anyway. This is the sprag clutch. This is not a ball bearing, it's simply a one-way drive. It has no bearing capacity. if I want to have a bearing, I've got to use this one, just an ordinary old 6204 with rubber seals on either side. And the plan is that the bearing will set into this pretty well on the center line of the chain, so all of the load when this thing is running is taken by the bearing, which is what it's designed to do. And then the drive consistent part of that will consist of input from the sprag bearing or the sprag clutch. I need to take a little bit of advice on that. One of the options is to put this in and recess it and then spot weld this and carefully manage the heat so I don't melt any of these seals. The same applies to the shaft this is going to go onto, which in turn is going to go onto this. I need to be able to make sure that I can drive from the starter motor into this inner ring and then transmit the drive into the sprocket. So that's got to be very robust, and it's absolutely essential that this has a one-way drive, so that if when the engine kicks and starts and the rollers start to be driven instead of driving the back wheel, then this can allow overrun without having the starter motor rev up to the point where it explodes. I'm back on the lathe again now, and what I've done is I've just set up a piece of steel, and without disturbing it, it's in the 3-jaw, which is always something you have to be careful about when you're thinking about accuracy. But this has been turned now in the 3-jaw and it hasn't been removed. So this is as good as I can get in terms of being concentric with the general axis of the lathe. So, and that's a great way of holding and carrying parts if you have them, if they're going to rotate and you have to keep them on center. So you turn up a shaft, you then put this on so it just fits, and then you put in some you secure all that then with a washer or a set of washers, something long enough, and then you have this secured on center with enough friction so that it will turn, and that will give me a nice concentric machined surface, and I can see just how well this is going to work out as an experiment, because this part is an original from the starter motor and it still has those useful splines in it. So if I can reduce this down, it seems to be quite hard. I've already managed to turn it a little bit, so with a carbide tip I'm going to see how this works out. So stand by for a little bit of machining. But I'm turning this nice and slow, plenty of cutting oil with a fairly fresh carbide tip. It's mounted on center and it seems to be holding its own. The feed on the lathe is about 2,000 per revolution. Well, as you can see, I've managed to turn down this piece of spline shaft so that both the sprag clutch and the ball bearing go onto it. I still haven't finalized my plans on this. It could be that I end up making an extension shaft here, which will be 20 millimeters, and I will end up welding the sprag clutch to it very gently. Right, I'm just using this little self-actuated punch. Just this will center pop all these items for the next stage, which is to start drilling. And there's the center. Right, that's one little chore done. Now an immense step forward in productivity will take place when I start drilling all this stuff. Alright, as you can see, I've got this set up. I'm going to drill all the holes together through all the plates. Every hole will go through as many plates as it needs to. I've got this bricked up here for some support, and I'm supporting both ends of it on these old keel rollers. So all in all, this should stay fairly stable. The drill will go through fairly normal to this surface, and all of the holes will be replicated in the other plate. It'll be close enough. It'll work. Right. You've all seen people drill holes before, so I'm going to turn the camera off now because it's in the way apart from anything else. Well, here you are after all the drilling. This is going to be a slot in one side where the little idler pulley goes, and then up here we've got another load of holes. This is going to be slotted so that this bearing can move a little bit to tension this side of the chain. So anyway, a little bit of progress. Well, this plate now is fully drilled. I've filed out some of these slots, so you can see this one here will be able to move and tension the long run of the chain. And then if I move the camera down to here, you should be able to see that will just put a bolt loosely in that. That'll go up and down and enable me to tension the run at the motor. So, progress. Right, I'm back on the lathe again now. This is the spindle. It's a piece of metal, a piece of steel, over 20 millimeters, and I've worked out that I need it to be 13 inches long. So I need 20 millimeters for a couple of inches here. Then I need to step it down to the hole, so that to the hole diameter in the rubber keel roller. And then at the other end I'm going to have to put a spacer tube on it to mate it up with the other bearing on the other end. So at the end of the day, one of the things which is very important whenever you're dealing with whenever you've got long shafts is that you have what's known as a fixed steady. And that just comes down. You can adjust the bronze slipper feet and then just adjust this, clamp it down, and then the bearing will support it. And this long shaft, instead of thrashing around all over the place, you can center drill it and take a cut on it, and everything's going to stay on line. Down at the other end here, I've only got about a ½ an inch of metal in the jaws, so it's just held on just enough to turn it and hold it at this end, and then the support here will keep it from thrashing, and I can work on it down here. So off we go. So what I'm doing is I'm putting a center in the end of this. That means ultimately I'll be able to put this end into a rotating center, and that means I'll be able to always take it out of the machine and put it back on center again. This should be the last cut. This should enable the end down here to fit in the bearing nicely at 20 mil, and then this should nominally be a 3/4 inch diameter, which will fit the hole in the rubber. And then I will have to reduce the end down there and turn up a spacer so that it will locate in the 20mm bearing again. Lots of stuff to do, but it's just simple turning and boring, and I'll get there. Well, this just shows you again the way this is going to work out. I've had to reduce this one here a little bit to go into the roller. Then I'm going to have the drive flange, and then I'm going to have this bearing. But in fact I need to reduce this little bit of shaft now to something like say 5/8 and make up a sleeve with a 20mm OD, which will locate on that, and then I'll be able to put a Woodruff key in the shaft through the sleeve, and well, it may not be a Woodruff key, it might be just a piece of threaded bolt going in, perhaps a bit of stainless. But anyway, this shaft is going to be keyed to this disc and this one over here, and they're going to have some bolts drilled through and into this, so that for about an inch on each end there will be drive fed into the thing. I don't think there's any point in trying to attach the rubber to the shaft. I might just put a little bolt through the whole thing and let that in effect be a sort of a drive key. I'll think about that. I'm making this up as I go along. The whole thing is just a bit of a fiction really, between one thing and another. I haven't bought plans for this, and I'm just having fun inventing something. Right, this just shows you progress so far. I've got the shaft here turned down to 3/4 of an inch, which just fits the roller. This is 20mm, and in order that this shaft will go through the rubber, I've put a little sleeve here, which means, hang on, that will go on there. So that's 20mm, 3/4, 20mm. And up here then I've got the plumber bearing. I've got a gap here which I'll be able to put a drive hub on, another scope for a drive hub, and the sprocket and the taper lock coupling. So roughly speaking, that's going to be the sort of width of the contraption so far, and that's wide enough and big enough, I think. Anyway, that's where I've got to so far. Next stage is turning up these little drive flanges and sorting out a little keyway. I think all I'm going to do is just drill and tap through and put a little bolt in. I'm just going to mic up this part of the shaft. This is for plan B. Instead of using the splines, I might just chop all this off, extend this shaft out. So that's 6 to 1.5. 6 to 1.5, right? Remember that. Right, I've got the mic. 6 to 1 to 2.5. Yeah, let's get plow clearance. That's nice. Happy with that. Don't know if that's in focus in the camera, but that's going to work out okay. So let me just deburr that sharp edge, and then I'll try this on the shaft. Right, this is just a little jig that I've turned up. Whenever you're going to repeatedly turn stuff and you need it all to be on center, making up a little custom-made spigot like this is a good idea. This is going to go on here up against the shoulder. This will go through here and locate on some threads, and then that will be tightened up against the flange. And that should rotate this on center, and that means I can take a skim off this unmachined surface, and because I can set the slide and the cross slide in the same position or lock it in position, it means in effect that I can turn all of these to the same thickness. So that's what the plan is. Right. There'll be enough friction there now to hold that, and that should be pretty well on center. Yeah, that'll do nicely. So I can just take a skim across that, and I can sort out the inside bit here. So let's just set this up. Touch off there, come out. Lock up the cross slide, and then put in, let me just set that to 0, put in 10 thou. See how it goes. Just that. Well, now that that job is done, I can think about the next bit of work which I intend to do with this little piece of scrap, really, which is in the chuck. What I intend to do now is just check out how successful it is to weld the inner race of something to this. So that will just about fit on there. So what I'm going to do is ease this down a bit further, so that in effect I have a little piece of shaft sticking out of this, and then I'll see about getting a weld here and how much damage is done to the sprag clutch, because the sprag clutch has got to take all the load, and I still haven't had any news through from Loctite. I'm pretty sure they have a product, you know, which I could use as an industrial adhesive, but I just can't get any contact with them. Well, I'm back again. Just another indication of some of the progress. I've decided to drive these rollers by putting pins through. There's the initial sprocket with the taper lock and some 4 pins. There's on the other one, the taper lock with the 4 pins, which will protrude through this plate, which in turn will have 4 more pins, and then these will all dovetail into this end here where there are 8 holes, and this will be pushed on. I've got some more pins to go here. At the moment I'm going to drive this part here by just drilling and tapping a 6mm bolt, and that will be in effect the keyway that will drive this, and all of these will be lined up so that they're all snug and comfortable. And then once the shaft starts turning from both ends of this roller, there will be something twisting it, and I might even drill and tap down through the middle here and just put a bolt through that. So hopefully this roller will be fairly well locked onto the shaft. So what I'm going to do now is just start drilling the shaft for this. I'm not going to cut a keyway as such, I'm just going to drill and tap some holes and put some bolts, and that should be adequate for the torque this has got to transmit. I'm just bringing this little wiggler in to the point where it touches. It's just started to preload the dial gauge, and there, any minute now, any second, there it goes. Yes, that's it, that is the edge. That reads 0, and it reads 0 on the hand wheel. So I'm going to turn that off now and feed it out 0.511. So one, 2, 3, 4, 5, and up to there. That is now the center line. So let me just lock that up. Well, here's the result of all that drilling. Some little 6mm bolts threaded in and Loctited in position, and that will now go on. So I can now tighten up the taper lock, and then this part will go on. And it'll drive down over those pins there, which will stick through and join up with these pins in gripping the rubber roller. Right, this shows you one completed end. The taper lock is all clamped up, and the drive hub has lots of pins coming through it, and in effect I'm just going to drive this on now into the roller. Well, as you can see, those pins are going in, and once this is hammered home, that will be one end of the drive then completed, and I'll just have to put another end on, and I'll show you that in a minute. Right, this just shows the tool I used to make sure that the rubber roller was fully engaged with all these pins here. I've just used some lengths of studding and the bearings to squash all this together. So I'm glad I thought of that, because it was getting kind of difficult to get this rubber. When you start beating something made of rubber, it's very good at absorbing all the shocks and so on. So in fact, even though I was whacking it at the end here, it wasn't really moving anymore. But this has worked well. Right, this is a view of the finished roller. Obviously I'm going to have to make 2 of these, and And what I'm going to do now to stop all these mild steel parts going rusty, I'm going to paint them. Let me just move this a little bit. You can see the keyway in there. If I turn around and get the sunlight in it, it might help. And all of these being identified with dots as well. So anyway, this is all going to fall together.